Welcome students, we are starting our study on definite integrals. Now before we could add on to understand the concept of definite integrals and then pursue further on by doing various problems, it is imperative we need to understand integral calculus. So the question is why? Why do we need to have integral calculus? Now we all know that there are several geometrical shapes. Say for example, I take the shape of a square and it has a side of s units. Now the area of this square is going to be side into side. In other words, it's going to be equal to s squared. Now say for example, we have a rectangle and the area is required, and we have this side to be the breadth and this side to be the height, and we would want to get the area of this rectangle. Then that area would be b into h. We can also call it as either breadth into height or width into height. So both ways you can make the representation for the rectangle. Now after the rectangle, let us see the parallelogram. So we got a parallelogram and you would want to know the area of this parallelogram. Now the width is b and the height, so whenever we are obtaining the height for the parallelogram, we would obtain the vertical height in this fashion, right? So the area of this parallelogram would be equal to b into h. Now let me go to the triangle. How we would obtain the area of the triangle? Say imagine the vertical height is h here and the base is b units, and the area is half times b into h. Now let us go to the trapezoid. Now the trapezoid is a quadrilateral and its shape is something of this fashion, and if this h is the vertical height and if this b is the base, then there is one more width here, so we should also take that width. Say let us give that width as a, since we have taken b here. So the area of the trapezoid is going to be sum of a with b divided by 2 multiplied with the height. Now let us take the circle, one last area. Now this is a circle. Now you want to find the area of the circle, we would need what is called as the radius, and the area is going to be pi r squared. So all of these shapes are symmetric. In other words, these are all defined shapes, right? So that is the reason we are able to take the sides and then we are able to obtain a formula for that. Now the most important question here comes is, what if I had been given something which has got no defined shape? How am I going to obtain the area? Now you might be asking why finding the area is important. Now look around yourself. Everything is a physical representation of the human mind. In other words, any shape that you see, be it a house or a palace or a mansion or a monument or an architectural building of great importance to the culture, everything is built on shapes. Without shapes, there is no representation at all. So to get that shape, you would require area. In other words, if tomorrow you wanted to build something of importance to represent your culture or the traditions that you have got, you need a monument. monument in mathematical term is called as a geometrical shape. Now, to construct the geometrical shape, you need measurements. In other words, we call it as dimensions. Now, dimensions can only be achieved or can only be obtained if the shape of what you are in mind as a perfect geometrical representation. Say you want something in form of a square or a rectangle or a parallelogram or a triangle or a trapezoid or a circle. And there are other figures also which I have not represented, which have a perfect symmetry and a perfect formula. But what if you want something which is of marvel? When I say marvel, I mean something which is unique in nature. Now, if you want to do something or create something unique in nature in form of a shape, then you need something different or something away from these formulas. And only then you can call it unique, right? Of course, you might, there might be claim that we don't have to, but if you are confining yourself to these predefined shapes, then the representational structure is going to be a predefined shape. That's it. But the urge to create something of different becomes more stronger with the creative mind. So what if you want to create a shape of this fashion? So that's the basic question that has been posed by great people with the mathematical bent. So you got the x-axis, you got the y-axis, and I would want to have a shape something of this fashion. Now, to bring this shape into existence, as I mentioned to you, we need dimension. I need to know how much area that this particular shape occupies. The basic way you can say this is what? This is a curve, and you got an area that is below the curve. That is the utmost representation that you can say. Say, for example, it starts from A and it ends at B. And there isn't anything further available as of the area is concerned or the concreteness of the shape is concerned, so that we can associate the shape to one of the things that we have just seen here or other things which have predefined structure or symmetric. So the requirement is to obtain this particular area. So what are we going to do? Now, what the mathematical bent people of those days did is that they thought, okay, why not I associate this particular shape to a symmetric shape that is well known. That was the idea they had, right? So always what exactly we do is to solve any complex problems, to solve a complex problem, we relate the complex problem to an easier problem that was previously solved. And then we take in inputs from this particular solution and try to break the problem into finite parts. So this is the general way of solving complex problems. So that is exactly what they did. So the idea is that they created a rectangle. So this went on like this, and this was the shape that they created, and they called it as a strip. So this rectangular strip that has been created will have a width. So the width is taken as dx, and dx is the most important point. This is a very important point, is negligibly small. That's the idea here. Now, because dx is negligibly small, this region that you see here, which flows out of the curve, is neglected. So this is neglected. Now, this is the concept that is being applied here. Now, why did they neglect it? Because dx is already negligible small. Okay, so having mentioned that, so this region which we see that is overflowing outside of the curve is neglected. And with dx being the width, we would like to know the corresponding y value, and that corresponding y value is given by y is equal to f of x. So the area that we see is a rectangular strip, and that area is given as width. You can call it as width or breadth, width multiplied with the height. So what exactly is the width here? The width here is dx, and what exactly is the height here? It is f of x. And we write it like this, f of x times d of x. So this is the area. But apparently the curve is flowing from, or the required area is from point A to point B. So to get that required area from point A to point B, what exactly they did is that they divided all the regions that is below this particular curve into rectangular strips. So you got a rectangular strip like this, and then this is a rectangular strip, and then this is the rectangular strip. So it kept on, the division went on up all the way until they reached the final end. So you got multiple strips, and you're expected to find the area of the region from A to B. So how are we going to represent? The representation was like this, S. So this is long S. So S stands for sum, the summation of the area of each of these rectangular strips has to be done from A to B. And what are we going to sum? We would have to sum f of x times d of x. And this is what is called as the area under the curve. And this is the whole idea of definite integrals. So I hope you understood the concept why exactly we need definite integrals. So now we head on.